Welcome to the History of Science series. In this episode, we turn to a man whose discoveries quietly power the modern world every single day, Michael Faraday and his groundbreaking discovery of electromagnetic induction. Michael Faraday was born in London in 1791 to a poor family. He received little formal education and began his working life as an apprentice bookbinder. But while binding books, Faraday read them, especially books on science. He taught himself chemistry and physics by candlelight, carefully recording his observations in notebooks that would later become famous. Faraday's life changed when he attended public lectures by the chemist Humphrey Davy at the Royal Institution. Faraday took meticulous notes, bound them into a book, and sent them to Davy, along with a letter asking for work. Davy was impressed, and in 1813 Faraday was hired as a laboratory assistant. It was the beginning of one of the most remarkable scientific careers in history. In the early 19th century, scientists knew that electricity could produce magnetism. In 1820, Hans Christian Ørsted had shown that an electric current could deflect a compass needle. But one crucial question remained unanswered: could magnetism produce electricity? Faraday became obsessed with this idea. In 1831, after years of experimentation, Faraday finally succeeded. He discovered that when a magnetic field changes near a conductor, an electric current is induced in the conductor. This phenomenon became known as electromagnetic induction. In one of his simplest experiments, Faraday moved a magnet in and out of a coil of wire connected to a galvanometer. Each time the magnet moved, the needle jumped, evidence that a current had been generated. Crucially, the current only appeared when the magnetic field was changing. A stationary magnet produced nothing. This insight was revolutionary. Faraday had discovered the fundamental principle behind electric generators. Every modern power plant, whether powered by steam, water, wind, or nuclear energy, works on this same principle. Mechanical motion creates a changing magnetic field, and that changing field induces an electric current. Faraday did not describe his discoveries with equations. Instead, he introduced the idea of fields, invisible lines of force filling space. To Faraday, electric and magnetic effects were not mysterious actions at a distance, but real physical structures extending through space. This way of thinking was deeply intuitive and profoundly new. Many mathematicians of the time struggled to understand Faraday's ideas, but decades later, James Clerk Maxwell translated Faraday's concepts into mathematical form, producing the equations that unified electricity, magnetism, and light. Maxwell would later say that Faraday was the true originator of the field concept. Despite his enormous impact, Faraday remained humble. He declined a knighthood, refused to profit from his inventions, and devoted much of his life to public science education. His Christmas lectures at the Royal Institution, especially those aimed at children, helped establish the idea that science should be accessible to everyone. Michael Faraday died in 1867, but his legacy is everywhere. Every electric motor, every generator, every transformer traces its origins back to his experiments. Faraday showed that deep insight does not require advanced mathematics, wealth, or privilege, only curiosity, patience, and careful observation. Thank you for watching another episode in our History of Science series. If you enjoy these narrated audio articles, be sure to subscribe and explore the full playlist for more stories about the scientists and discoveries that shaped our understanding of the universe. More episodes coming soon.